Okay, a couple more examples to go over. This is another really good example. Um, okay, only 5% of male high school basketball, baseball, and football players go on to play at the college level. Of these, only 1.7% enter major league professional sports. 0.01% of high school athletes are able to make the jump immediately from high school to the professional level. Make a tree diagram to show the different possible scenarios and their probabilities. Okay, so we're saying that A is going to stand for competing in college, and B is going to stand for competes professionally. Okay, so we start with a randomly chosen male athlete, high school male athlete. Okay, now that male athlete could compete in college, so that would be A. Or they could not compete in college. It's not about going to college or not going to college, it's about competing. Okay, so a randomly chosen male high school athlete could go on to compete in college or not compete in college. Okay, so up here it said 5% go on to play at the college level. Okay, so 5% would compete in college, so that's 0.05. Okay, the complement of that would be 1 minus 0.05 or 0.95. 95% do not compete in college. Okay, then let's look at the next level. So of these, of the 5% that compete in college, 1.7% go to major league professional sports. That's B, competes professionally. So, of the players that play at the college level, 1.7%, or if we move the decimal place, hang on a second here. If we move the decimal place, 0.017, 1.7% of these people go pro. Okay, so if 1.7 of them become professional athletes, then the complement of that would be not pro, and that would be 1 minus 0.017. That would be 0.983. Okay, so they might compete in college and they might go professional or they might not go professional. Okay, then down here it says 0.01% are able to make the jump immediately from high school to the professional level. So they did not go to college, but they did go pro. So they did not they did not compete in college. They might have gone to college, but they did not compete in college, but they went pro. That's 0.01%. Well, if I move that decimal place, it would be 0.0001. Okay? Or an athlete could not compete in college and then not be pro. So the complement would be not pro. So that would be 1 minus 0.0001. That would be 0.9999. Okay, now we have to do some multiplying. So now we're going to multiply 0.05 times 0.017. And we get, that's an equal sign, 0.00085. Okay, now we're going to do 0.05 times 0.983. And we get 0.04915. Okay, then down here we're going to do 0.95 times 0.0001. And we get 0.000095. And here we're going to do 0.95 times 0.9999. And we get 0.949905. Okay, so then to answer the question, it says, what is the probability that a high school athlete goes to the professional level? Okay, so a high school athlete could go pro either by competing in college, so that would be that, or they could go pro by not competing in college. That would be that. So what's the probability that a high school athlete goes pro? That would be 0.00085 plus 0.000095. Okay, because those are all the probabilities of B, which is going pro. So add those up, you get 0.000945. And then as a percent, that would be 0.0945%. Very small percent of high school athletes go pro. Okay. Okay, this type of problem is going to come up a lot. So we'll do one example now, and then we're going to do lots more examples throughout the next few days. Anytime you see at least one in a problem, it's going to be kind of like this situation. All right, people with type O negative blood are universal donors. Any patient can receive O negative blood. Only 7.2% of people have O negative blood. If 10 people appear at random to give blood, what's the probability that at least one of them is a universal donor? So at least one of them has O negative blood. So out of the 10, at least one, could be 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. Well, finding all those probabilities and then adding them up would take longer than using the complement rule. So that's what we're going to do. We're going to use the complement rule. So we're going to find the probability that at least one O negative, okay, that would equal 1 minus the probability, so what would be the complement? What's like the opposite of at least one? That would be none have O negative. So the probability that none of the 10 people have O negative, 1 minus that would be the probability of at least one. Okay, now we need to do a little bit of side work over here. So if 7.2% of people have O negative, then what percent do not have O negative? That's what we're trying to get here. We're on our way to figuring this out. Then 92.8% do not have O negative. Okay, so the probability of one person not having O negative the probability of one person not having O negative would be 92.8% or 0.928. Okay, but we're talking about 10 people appearing at random. We want the probability that none of the 10. So here's the probability of one person not having O negative. We really need the probability of all 10 not having O negative. Okay, so the probability of all 10 people not having O negative, that would be 0.928 to the 10th, because it would be 0.928 times 0.928 times 0.928 times 0.928, 10 of those for the 10 different people. So this would be 0.4736. That would be the probability of all 10 people not having O negative. So that would go here, 0.4736. Now if we do 1 minus that, then we will have 0.5263. Okay, so I'm going to type this out so that the writing looks better. So the probability that at least one of the 10 people So the probability that at least one of the 10 people is a universal donor is 52.63%. Okay, the last topic that I want to talk about is the idea of independent and mutually exclusive. So to review, mutually exclusive is when two events cannot happen at the same time. And independent is when the probability of one event happening does not affect the probability of the other happening. Okay, so the question up here is it possible for two events to be independent and mutually exclusive? This type of question pops up all the time. Okay. All right, well, think about if they're mutually exclusive. Okay, if they're mutually exclusive, then they cannot happen at the same time. So if they're mutually exclusive and one event occurs, then the other can't, and so the probability of the second event goes to 0. So when they're mutually exclusive, if one occurs, the other cannot occur. So if one occurs, then the other one's probability drops